Welcome to Algebra, combining like terms. In this lesson, we will review the idea of combining like terms, an important skill in simplifying expressions and solving equations. The first and most important task is identifying terms that are alike, or recognizing when they aren't. Read through this common misconception, and then we'll work through this star test example. Let's take a look. The question says which expression is equivalent to 5rt minus 3rw minus 8tw, the first group in parentheses, plus, and in parentheses, 6rt minus 4rw plus 2tw. Well, the first step is to recognize that the plus sign in the middle simply adds that next group of terms. And so when it is a plus sign, we can simply take away all of the parentheses, ending up with the expression 5rt minus 3rw minus 8tw plus 6rt minus 4rw plus 2tw. The next thing to do is to recognize the terms that are alike. The first set of terms that are alike are the 5rt and the 6rt. When those are combined, you simply add the number in front, and so that totals 11rt. The next pair that are the same are the RWs. So you have negative 3RW and negative 4RW. Combined, we get minus 7RW. And finally, negative 8TW plus 2TW combines to make negative 6TW. And so the answer you see here is B. Before we go on, we need to look at the different parts of the expression given. What do we call these things? Variable terms in this case are 6x, 2x, and negative 5x. Those are the terms that contain variables. Coefficients are the numbers that are in front of the variables, 6, 2, and negative 5 in this case. We have two constant terms, and a constant term simply means there is no variable. It is simply a value. 7 and negative 3 are the two constants here. And the only variable that we have is x. Combining like terms is a way to simplify an expression by taking the terms that are alike and combining them. What are the terms that should be combined here? What are the like terms? Well, first of all, we have 6x plus 2x and minus 5x. Those will combine first to be 8x minus 5x, and then finally 3x. What else could be combined? The two constants. So 7 and negative 3 make 4. And so the final answer is 3x plus 4. This is now the simplest version of this original expression. Let's try a set here. So we are to simplify these expressions by combining like terms if possible. Now, it would be helpful to circle or underline the terms that are alike as you go along. These first few are fairly simple. In this first one, 5a and 2a are like terms because both have the variable a, and they combine to be 7a. In the next one, we have 7x minus 5 plus 3x. Well, the x terms are alike, and so those combine to be 10x, and then we have the constant minus 5. In the next one, 8a and 10a are indeed alike because they share the variable a. And so we combine the coefficients of those two, and we get negative 2a. In the last expression, we have 2x and x, which are like terms, which combine to be 3x, and then 5a and 4a combine to 9a. 3x plus 9a is correct, but a better way to do it is to put it in alphabetical order. 9a plus 3x. Both answers are correct, but traditionally in algebra, final answers are written in alphabetical variable order. You try these three expressions. Let's look at the first one. In the first one, the 2x terms, 5x minus 7x, become negative 2x. The next two terms, 2y and 3y, combine to make 5y. In this middle expression, the y terms combine to make negative 9y. The constant values 3 and 5 combine to make 8. And that leaves 2x as the final term. Now, we express this in alphabetical order, and so the 2x goes first, minus 9y, and then plus 8. In the final expression, 15x minus 10x becomes 5x. The y terms combine to make 10y, and then 11 is the remaining constant. When we put them in alphabetical order, 5x plus 10y plus 11. With terms containing powers, bases, and exponents, only like terms, ones that have the same base and same exponent, can be combined. We have three expressions here. Only one of these three expressions contain like terms that can be combined. Which one, and why not the others? In this first expression, we cannot combine them because they have the same base but different exponents. In the second one, we cannot combine them, even though they have the same exponent but different bases. In the third expression, these are like terms. They have the same base, the same exponent, so we can combine the coefficients. 6 plus 4 equals 10, and the base and the exponent stay the same. Try these four expressions, simplifying them by combining like terms if possible. In this first one, we have 4a cubed plus 2a cubed. Those are like terms because a is the same base, 3 is the same exponent, and so 4 plus 2 is 6. The answer is 6a cubed. In the second one, likewise, x squared is the like term, so 12 minus 5 is 7. Final answer, 7x squared. In the third one, the two b squared terms can combine, so 9 plus 2 is 11b squared, and then plus 4b. When power terms have the same variable bases, but with different exponents, list them in descending exponent order. In this last one, the two x cubed terms can be combined, so we have 8x cubed, and then 2x plus 5x makes 7x. Final expression, 8x cubed plus 7x. For expressions containing different variables, list combined terms in alphabetical order. Remember to list power terms with the same variable in descending exponent order. Any constant value left over goes at the end. Simplify these expressions and list the final terms in the correct order. Let's take a look. Here you have the two x terms, 3x squared minus 5x squared. Those become 2x squared. The y terms, 5y and 2y, combine to make 7y. Final expression, 2x squared plus 7y. In the middle expression, the two x terms, 5x minus 3x, become 2x. The z terms combine to be negative 3z. And then the 6y term is left over. We put them in alphabetical variable order, so 2x plus 6y minus 3z. In the third expression, you have m cubed terms. 4 minus 2 becomes 2m cubed. And then the two n squared terms, plus 5 minus 5, that becomes 0n squared. And we don't list that because terms with 0 coefficients are not listed. 0 times anything is just 0. Try these two. Combining like terms can be used in geometry, as you can see here. Write the expression that represents the perimeter of the following. This is a practical application to combining like terms. So we have three sides, 3x plus 5, 5x, and 2x minus 3. We don't know exactly what x is, but we can simplify the expression. So we can combine the x terms to be a total of 10x, and then the two constant values total 2. So the final expression for the perimeter of this triangle is 10x plus 2. In this rectangle, the four x terms combine to be 10x, and the four constants, negative 3, plus 1, and plus 1, combine to be negative 4, and the final expression is 10x minus 4.